Little background information. When I'm expressing something in these brackets here, I am expressing a concentration of that specific thing, and it's going to be expressed in molarity. And that's going to be moles per liter. So this is going to be my base concentration, my hydroxide ion concentration, but something new is this tonight. Okay, when I multiply my hydronium or H plus ion concentration by the hydroxide ion concentration, I will always end up with this number. 1 times 10 to the negative 14th. And that's huge. We're going to be using that a lot tonight, and so just get ready to use it, dudes. The steps necessary are 2. So in order to calculate the pH given my hydroxide or base concentration, I need 2 steps. The first is going to involve solving for the H plus ion concentration. Now I'm going to use this right here, guys, the brand new formula that I showed you. So if I give you this, if I give you that, and you also are given this, we're going to use a little bit of algebra to rearrange the equation to say the H plus ion concentration is going to be equal to 1 times 10 to the negative 14th divided by the hydroxide concentration. And that's going to be expressed in the problem. You'll have that number. Step 2 is going to now plug this value into my pH formula. Remember, the pH was the negative log of the H plus ion concentration. Once you have that number, you plug it in down here, and you're going to find yourself the pH. Also, viewers, check this out. When I mentioned H plus, I could also interchangeably be expressing the H3O plus ion concentration. They're often used in the same exact way. In our first example tonight, we see we are asked to calculate the pH of a solution, and the solution is a base. I have a hydroxide ending, the OH ending, and the hydroxide has a concentration of 3 times 10 to the second molar, negative second molar. Step 1 we're going to use, the same as before, is going to be to use my formula, the H plus concentration plus my OH or hydroxide ion concentration equals 1 times 10 to the negative 14th. That's always going to be, part of my first step. Is going to be use that equation to solve for my H plus ion concentration. When we rearrange this, as we saw before, the H ion concentration is going to be equal to 1 times 10 to the negative 14th divided by my hydroxide ion concentration, which the problem tells us is 3 times 10 to the negative second. Once I crunch those numbers of 1 times 10 to the negative 14th divided by 3 times 10 to the negative second, I find out that the hydrogen ion concentration is going to be equal to 3.33 times 10 to the negative 13th. So that is part 1. I kind of have my hydrogen ion concentration right now, right there. And that is really cool. Awesome part. I see that my exponent value is around 13. That means my pH, just a little, heads up, your pH should be around there. My pH is going to be between 12 and 13, most likely. That's what that exponent is going to give me a little heads up for. Step 2, we're going to use that ion concentration in my pH formula, because the pH of a solution is equal to the negative log of the hydrogen ion concentration. And when I substitute that previous value into this formula, and then take the negative log of that, we find out that the pH is going to be equal to 12.5.